Hey guys, good morning. I wanted to record a quick video for you guys. It was just a trial and error on how I could record future online lessons. And today's topic is going to be about linear equations. I saw my little brother doing linear equations outside, and I was like, might as well. Since we've also been learning this for a while, and it really does traverse a number of years in high school. So I've seen some students like Darius started at year 7, goes up to year 11 with my other students. And it's really not that hard of a concept. I'll have another video on my iPad that hopefully I'll be able to sync on here for you guys to see. And when you do linear equations, try to have graph paper. You can get them from Kmart or something really cheap. Quick EduMax General. Yep. So it should work out here, and I'm just gonna be syncing it. So I should use it sideways, right? Right, I should probably do this sideways. Okay, I might cut some parts out. And yeah, all right. So first things first, what do I want to do with linear equations? I want you guys to know what are linear equations, right? So a linear equation is essentially a mathematical equation that describes a straight line. So we have something like a linear equation. I'm going to write it down here. Linear equation. So equation, what does that mean? It means it has an equal sign, right? If it has an unequal sign, we call it inequation or inequality, right? Linear means it has the word inside. The root word is line, okay? So we're essentially trying to think of a linear equation as the clothing of a line, okay? So it gives it identity, okay? Every line has an identity. You can draw it on a Cartesian plane any day you want, but you can't really name it and continuously draw it unless you have its equation, okay? So for example, y is equal to 2x, y is equal to 3, x is equal to 7 plus y. These are all linear equations. You might know the equation form. General form. What is the general form? Okay, give it a go. Some people might use B, so I'm just going to put it there on the side. But we like to use generally C, okay? What is M? M is... Okay, and what is C? So remember, to actually get to use or deduce these qualities of a linear equation, you have to put it into slope-intercept form. I called it general form, but really it's the slope-intercept. You can see why it's called slope-intercept. A gradient is essentially a slope, and C is the y-intercept, right? And yeah, essentially these are all. Is this one in slope-intercept form? No, but it's very easy to change. You just move the 7 to the other side, so it will be y is equal to x negative 7 plus x. I know a lot of my students, they have sort of fussy with this. they want the y on the left side, and they want it to look like this. They're not comfortable with negative numbers. Okay, and just a quick note, what's in front of x here? In front of x is a cheeky 1. Okay, use y. So the m in this is 1. Okay. And yeah, so that is the first bit of linear equations. Let's look at y is 2x plus 1. Oh, before that, I want to see. Let's say 2x minus 3y is equal to 7. What form is this? This is another form of linear equations. Simply, if you want to graph, if you want to solve anything with it, very easy. You just make y the subject. Okay, so you move x to the other side. How do you do that? Minus both sides by 2x, right? And then you divide both sides by negative 3. So y is equal to 7 minus 2x over negative 3, okay? So put the negative on the outside and then 3 on the bottom for the whole thing. Remember, when you divide it, it's for the entire right-hand side, okay? So y is equal to, now we can separate the fractions, right? Remember, when you add fractions, it's like a over b plus c over b. It's equal to a plus c over b. What does that mean? If the denominator is the same, we can just add the numerators. Similarly, we can break them apart. Okay, so we have 7 minus 2x over 3. It's actually 7 over 3 minus 2x over 3, right? But don't forget there's a negative on the outside here. Okay, I'm just gonna draw it with black. Do you see this? Okay, it's actually brackets like that. Okay, so why is that important? We want to distribute it later, okay, via the distributive law. So now let me just go back to here. Okay, it's not really in a form you're used to, but remember when you have a fraction like that, minus 2x over 3, it's actually 2 over 3x. Okay, and now your entire gradient is solved, and you just want to rearrange it so that x is at the front. But before I do that, distributive law, so we do y is equal to negative 7 over 3. Negative and negative is plus, so plus 2 over 3x. That's it. And now rearrange it so that it would be 2 over 3x minus 7 over 3. Therefore, from here, we know that the gradient is 2 over 3, and the y-intercept is negative 7 over 3. Quickly looking, what would that look like? Where's negative 7 over 3? It's around negative 2.33, so it's around here. Let's say that's 2.33, so it will pass from here. And what is this gradient? 2 over 3. So for every 2 it rises up, it will go across 3. So something like this. So it's not exactly 1, but it will be like that. Okay? Yeah, that's it. Okay? It's okay stuff. I'm not gonna say it's easy. I have a bad habit of saying it's easy. But it wouldn't be as it's not the hardest thing you'll learn. And quadratics, after you learn linear equations, is very similar. Okay, so once again, any linear equation is essentially something with two variables. Really, that's it. And it doesn't have to be x and y. Sometimes you get p, you get q, you get x, y, you get a, b. But you want to differentiate these. These are variables. There's other things, coefficients. I've talked about these before. Try to familiarize yourself with what these mean. We said these are variables on the left. We also have constants, right? So constant in this case would be c. Okay, c for constant, and it's just any numbers really. That's not tied to a variable, but a number that is tied to a variable is called a coefficient. So like 2x, 2 would be the coefficient plus 1 would be the constant. Okay, lovely. So that's essentially that. Let's look at y is 2x plus 1 really quick. This is a straight line, so let's look at it. So from what can you see already? Y is 2x plus 1. It might be written in another way, like let's say y minus 2x is equal to 1. Just rearrange it. So you're looking at slope-intercept form. Y is 2x plus 1. What can we get from this? I'm gonna draw the general. It will look like this. Oh, I've got GoodNotes, doesn't have to use. Okay, so this is y is 2x plus 1, and let's say if I had to note everything 1, 2, 3, 4, 5. That's why it's good to have grid paper, guys. I'm gonna buy a few grid paper books for my students if I see you guys this week or next week. Okay, so let's look at it. 2x plus 1. Where will this line intercept? It will intercept at 1 because of this, right? Now 2x, what does that mean? For every 2 it goes across, 2 it goes up, it will go 1 across. Remember, m is slope, okay? So it's how slopey something is according to the graph, this angle. So, but remember, slope is also called rise over run. Why is it called rise over run? Rise sounds like what? Sunrise, so it goes up. So that's how we call it the y, okay? And run is sideways, you run sideways, so it's x, y over x. So what do you have to have for y, and what do you have to have for x for it to be equal to 2? You'd have to have 2 over 1, right? You can have 4 over 2, it doesn't matter, it'll simplify to 2 over 1. So 2 over 1, so for every 2 it goes up, so it has to go from here to go up to 1, 2, and 1 across here, so the next point is here. Similarly, 1, 2, next point is here. Okay, I'm gonna rub these out so I don't confuse you guys. Okay, perfect. Okay, one more. Yep, and that is our line, guys. Really, it's not hard. Oh, that was a horrible line. But yeah, that's y is equal to 2x plus 1, right? Lovely. It shouldn't be too hard, okay? Let me see. What is another form you guys might get? Something like y minus 2 is equal to 3x plus 1. So what do you do here? You expand. I'm going to use another pen. I don't use a fountain pen. So y minus 2 is equal to what? 3x plus 3, right? Remember distributive law, okay? And then you just resolve. So y is equal to 3x plus 5. You move the negative 2 to the other side. Okay? What about this? Y over 2 is equal to 3. Is this a linear equation? Yeah. So you just do y is equal to 6 times both sides by 2. Okay, but one thing, linear equations don't have what? We don't have squared. So no, that. What is it called if we have a square? We call it quadratics, okay? Okay, I'm just gonna write it like that. You guys understand quadratics, and they don't have cube roots or square roots, okay? So none of these. Linear equations not equal to these, okay? It doesn't have these, and it doesn't have any order of n that n is greater than or equal or greater than 1, okay? Y, n to the power of 1 is just x, y. But if it's x squared, y squared, you get something like a circular relation. If it's just x squared and y, you get quadratics. If you get x cubed, you get, you start to get sigmoid functions and stuff. You'll start to learn those, but really the essential ones is just linear, and then you need to know quadratics, a little bit of cubic, and then the rest, you'll start to see it forms a very similar structure, so they all look pretty much the same afterwards. Let me see what else to quickly teach you guys. What if we have let me see, give me a second, guys. Okay, so there's not much, but I was doing this with my student Ava yesterday. What if, let's say, okay, so you know how to, from a line, you know how to get the equation. So you know how to get the, how do I say this? You know how to get the equation of the line. So you know what the line's name is. If I give you 2 points, can you solve for the linear equation? So for example, I give you 3, 4, and I give you 2, 3. Okay, so I give you 3, 4, and 2, 3. You have 2 points. Okay, these are what we call coordinates, right? Okay, 2 coordinates, what do you do? Well, I'm going to quickly show you. In the first way is to just substitute it in. Okay, the other way is you can plot it on a graph. So first I'm going to write a graph. Okay, this is not good because sometimes if you get a more complicated linear equation, all small human errors which we all make, if it's slightly off by a bit, the line will look like it's off by a bit, and when it touches the y-intercept, it might be off by 1 or 2, and you'll get the equation wrong. Using this way is infallible, essentially, if you can get your algebra right. So y is equal to what? mx plus c, right? Good. Now we just substitute 0.1 in. So I'm going to put this as 1, this is as 2, like that, okay? So number 1, we have x and we have y, we have x and we have y. So we just put it into this equation, right? So 4 is equal to m times 3 plus c. 3 is equal to m times 2 plus c. Do you know how I got there? You just put the 2 from here into x. And you put the 3 here into x here, right? Similarly, y into here, y into here. Where? From this equation, right? Okay, continuing on, I'm just going to rearrange it so it looks a bit more natural. It's equal to 3m plus c. 3 is equal to 2m plus c. Okay, lovely. So here we have our 2 equations. Okay, what do we do now? Let me equate them for you. So let me move this over. Okay, now you'll start to see, oh, this looks like something we can simultaneously solve. Minus both equations, c minus c is 0, 3m minus 2m is m, and 4 minus 3 is 1. So we have m is equal to 1. The gradient is equal to 1, okay? In whatever way you want to do this, you can rearrange it so that c is the subject as well. For example, don't want to do that right. I'm not going to do it now, I'm a bit lazy, but I'm going to do it now. I'm lazy, but I already made this video anyway. Okay, so 4 is equal to 3m plus c. Rearrange it so that c is the subject, so c is equal to 4 minus 3m. Makes sense? Move the 3 to that side. Now we just put this c into here. So 3 is equal to 2m plus c. 3 is equal to 2m plus brackets 4 minus 3m. So 3 is equal to 2m plus 4 minus 3m. 3 is equal to negative m plus 4. Negative 1 is equal to negative m. So m is equal to 1. Okay? So that was a annoying way, but same thing, you see. So this is through elimination, and this is other one was through sub. Okay, so these are the two ways to solve a simultaneous equation. So m is equal to 1. What do we do with m is equal to 1? We have another thing we need to find, which is c this time. Put this into any of these again, doesn't matter. Let's use the first one. So 4 is equal to 3 times 1 plus c. How do I do that? M is equal to 1, so you put it into this m, right? So you get 4 is equal to 4 plus c. Therefore, c is equal to 0. What does that mean? It just means we don't have a y-intercept, or intercept at y is equal to 0. Right? So ultimately, don't forget, put it back into the equation. Y is equal to x. That's it. Because it would be y is equal to mx plus c. M is 1 and c is 0. Right? So it's just y is equal to x. And that is our equation. And it will look like this. So not like that, but it will look proportional when it grows. Okay, it will grow 1 for 1. And it will intercept at 0. Quickly, I'm going to talk about perpendicular and parallel lines. Okay? This won't be long. Maybe 1 minute. Okay? I'm going to write this down really quick. And this one, m1 is equal to m2. What does this mean, guys? So I give you m1 is equal to m2, and m1 times m2 is equal to negative 1. M1 is m2. M is equations, the gradient of line 1, and m2 is the gradient of line 2. What does it mean when m1 is m2? It means that they both have the same gradient, so they're both the same slope. Okay, they're going to look like that, essentially. They might have different y-intercepts, but that's what the lines are going to look like. It looks like train tracks, right? Because they'll never touch. So parallel means that they run in the same slope. Okay, remember that. So if I tell you a line is gradient, they're parallel, you say like y is equal to 2x plus 1. The second line has to be y is equal to 2x plus c. You don't know where it's going to intercept, but you know that the gradient is 2. Okay? And what about for perpendicular? It means that they look like this. Look like the Cartesian plane. Okay, the axes. But it will look like that, and the other line will look like that, okay? What does it mean? Why is it m1 times m2 is equal to 1, negative 1? It means that they're opposites of each other. So they're at 90-degree angles, okay? So essentially, I'm going to give you a shortcut and just look back at this video if it doesn't make sense. m1 times m2. So if the gradient was, like this case, 2 times m2 is equal to negative 1. m2 is equal to negative 1 over 2. Divide both sides by 2, right? So you can see what happened here. To get to the second perpendicular, the perpendicular line's gradient, you just, you get the first gradient, you put it over 1, and you give it a negative. So if it's y is equal to 3x, what is the perpendicular gradient? It would just be negative 1 over 3. What if it was 1 over 2x? Like that. The gradient is just put it over 1 again, which is back at the top, negative 2x. So this would be the gradient this time. Okay, so these are for perpendicular lines. And if you graph it, you'll see that they're directly like an X. They form an X. Okay, so that is essentially it for now, guys. Let me know if you guys want any more help. And yeah, hopefully this was a good explanation video for linear equations.